without trial and error, okay? What I have right now is I have the polynomial 4y squared minus 17y plus 15, okay? This is the polynomial in question, all right? These are the difficult ones because that first term has a coefficient, and that's what makes it difficult because you have to basically find factors of 4 and 15, which is 60, that when added together will give you a negative 17. Okay? So I listed out the factors here. 1 and 60, well, their sum is 59, positive or negative, right? 2 and 30, well, the sum there is 28, 32. No good. 3 and 10, 3 and, where, 3 and 20 should be, 3 and 20. 4 and 15. Those don't anyway add to be a 17. But 5 and 12. 5 and 12. What if I made negative 5 and negative 12 my factors of positive 60? Would those two numbers equal a positive 60 when multiplied, but equal a negative 17 when added? Okay, so I have just found factors of positive 60, which is the product of these two terms, factors of positive 60 that when added together will achieve a negative 17. Okay? Now, I take that first term, write it. I take the last term and I write it. Okay? Now this is where there's some steps involved. Pay attention. The factors are 5 and 12, negative, right? Well, I know that 5 has a relationship with 15. They're both divisible by 5. And I know 12 would have a relationship with 4 because they're both divisible by 4. So I can list these factors in either spot, but I am going to list them next to somebody they share something with. The 12 and the 5, and you keep the y listed with it. Okay? Now, I am going to take this and I'm going to factor out what they share. They both shared a 4y. 4y came out, leaving me with y minus 3. Both of these two pieces shared a negative 5. The negative 5 came out, leaving me with, oh look, a y minus 3. Therefore, the resulting factor is 4y minus 5, both of those items being multiplied by y minus 3. This, in a nutshell, is what I'm going to try and share with you today. Okay? This is what I'm going to try and share with you today. Okay, I'm going to do some odds with you using that technique so that you can see it firsthand, like it, don't like it, whatever works for you. I am going to start with number 23. Okay, this is in your book on page 191. Number 23 is 2t squared plus 5t minus 3. Okay? Multiply the first two terms together and you get a negative 6. Right? If I just multiply the numeric values together, I get a negative 6. So what I want is factors of negative 6 that somehow, when added together, will give me a positive 5. So your factors are 1 and 6, 2 and 3, right? What if I did a negative 1 times a positive 6? Would I get the negative 6 that I needed? When I add together the negative 1 with the positive 6, will I get the positive 5 that I need? Okay, so the factors I am choosing are negative 1 and positive 6. Okay? So factors of this that when added together equal this. Write the first term and the last term down. 2t squared negative 3. Write these items with that variable attached next to a number that they appear to factor best with. I am going to keep the 1 here, and I am going to keep the positive 6 here. Okay? Because I can see that these two will share a 3, and I could see that these two will share a t. Okay? So now I'm going to try and factor anything out of what is shared. In this case, I know a t can come out, and that gives me t minus 1. And for this one, I know a positive 3 can come out, which gives me t minus 1, which means that t plus 3 multiplied by t minus 1 is the factor. Okay? This is repetition and practice, folks. It's not anywhere in your book. I found it on Khan Academy. That's number 23. Let's do number 25. Number 25, 3p squared minus 7p minus 6. Okay, the product of the first and the last is negative 18, right? The product of the first and the last is negative 18. I need to find factors of negative 18 that when added together give me a negative 7. So 1 and 18, and I'm not even including the positives and negatives. 2 and 9, 3 and 6. What factors of negative 18 when added together will create a negative 7? 2 and 9, it has to be a positive 2 and a negative 9, though, in order to create a linear negative 7, right? Bring down the first piece. Bring down the last piece. Attach the linear variable p to both of these pieces, and then place them next to whichever one you think they would factor best with. The 2 could factor with this very well, but not with this. And the 9 can factor with either one. So I am going to put the 2 next to the negative 6, and it has to be positive, and I am going to put the 9 next to the 3, and that has to be negative. Okay? The other way, it wouldn't work. You wouldn't be able to take anything out of that. Break them into pieces. Find what they both share. Here, I'm going to pull a 3p out, which leaves me with p minus 3. Here, I'm going to pull a 2 out, which leaves me with a, oh look, p minus 3. Since both of these pieces are being multiplied by the same thing, these two go in a parentheses together. 3p plus 2, p minus 3. Okay? Any questions so far? Yes, ma'am. Yes. 2t, 2t, 2t. 2t. Okay, any other questions? All right, other than my maleficent error, let's go on to 27. Okay, 27. 6x squared minus 7xy minus 3y squared. Don't let the letters fool you into thinking that this is impossible, still using the same method. Okay? Product 6 and 3 is negative 18. Same product. Isn't that interesting? Factors of negative 18, good grief, that equal a negative 7. Same ones, isn't it? Negative 9 and 2. So let's pull down 6x squared and 3y squared. We've determined that it's a positive 2 and a negative 9 that are the factors that both create a negative 18 when multiplied and create a negative 7 when added together. So, we want to put the 2 next to whichever one it most comfortably plays with. I'm going to put it here because those both share a 2. And we want to put the negative 9 in the other spot because it will play well with the 3. Let's factor. Break it here and here. Pull out a 2x and you end up with x plus y. That should be 3 there. Pull out a 2x and you have 3x plus y. Over here, let's pull out a negative 3y. And you have 3x plus y. Since both of these are being multiplied by the same thing, these collect together into parentheses, 2x minus 3y, and get multiplied by 3x plus y. It works every time. And it is much more time effective than the other way. Okay? So your first step, multiply the first and last piece, get the product. Your second step is to find factors of that product that when added together create that linear coefficient. Bring down your first and your last terms. Take the factors that you identified, attach the middle variable, grouping them with what you think they can most easily be factored with. Factor out what they share. If you're lucky, you will identify that both of them are being multiplied by the same thing, which then leaves you with those two pieces in parentheses.